Okay, so concept number 1 is all about factoring by GCF, and GCF stands for greatest common factor. Okay, so our objective for this lesson is I can factor polynomials. Make sure you write this down. It's important to know what the goal of this lesson is. By using greatest common factor. You can abbreviate it GCF. Okay, so this is really, really important stuff. Okay, so let's review for a little bit. Let's multiply some polynomials here. So simplify the following. All we have to do here is distribute. So a times 3a is 3a squared plus a times 7 is 7a. Okay? So we're distributing in all of these, all right? Basically, factoring a GCF is undistributing, is a way you can think about it. So we'll distribute here. Negative 2m times m squared is negative 2m cubed. Negative 2m times positive 6m is a negative 12m squared. And then negative 2m times negative 1 is a positive 2m. Remember, a negative times a positive is a negative. Negative times a positive is a negative. Negative times a negative is a positive. Okay? And then finally, let's distribute these ones. 5xy times x, well, there's still 5. I have two x's, so that's x squared, but I still have one y, so he stays there. And then 5 times 2 is 10. I have one x, but I have two y's now, so xy squared. Okay, so it's a little bit of a review from our unit number 6, multiplying polynomials, distributing. Okay, so what is factoring? Factoring is the process, like what's the point here? We're making things simpler for ourselves, of separating a polynomial back into a product. Just like I said, we're taking a complicated looking polynomial and we're splitting it up into a product of two smaller polynomials, okay? So sometimes you'll get a polynomial that can't be factored, and that is called prime. A polynomial that cannot be factored is called prime. Okay, so in this example, there are 24 questions. We're only going to do half of them in the video, the odds, and then we'll do the evens in class, okay? So I'm going to pause this here, and I'm going to start the next video with down here, okay?